59. Solve the following logarithmic equation. Log x to base 3 is equals to log 2x to base 9 is equals to 2. So as usual, when you are solving logarithmic equation, you must have the same base. So if you have log a to base b, that is log a over log b, isn't it? So here if you have log 2x to base 9, that is log 2x over log 9. So for you to get to base 3 here, meaning 9 is the same as 3 squared, isn't it? So this square power is the coefficient, isn't it? So this power becomes the coefficient. So what do we have? We have here 1 over 2, isn't it? 1 over 2. Then log 2x over log 3 means what? It means log 2x to base 3. The base is the logarithm in the denominator, isn't it? So it means this log 2x to base 9 can be written in that form, isn't it? Are we together? So here we have log x to base 3 minus the whole of this. We've simplified it in rough work and we found it to be a half log 2x to base 3. So on that side of the equation we have the same base, isn't it? Yes. Are we together? So on the left hand side of the equation we have the same base. Then you go on the right hand side, the equation is equals to 2. Meaning the other side, we introduce log 3 to base 3. Because a log of a number to the same base is 1. Good. So we now have base 3 throughout. So the next step is to get rid of the coefficients, isn't it? So we don't have the coefficient here. We have log x to base 3 minus this a half becomes the power of everything. Power of 2x, not power of x alone, isn't it? Yes. So it means it is minus log to base 3, then 2x is raised to power what? A half, isn't it? Yes. That one is equals to log 3 to base 3, then this 2 becomes the power, isn't it? Yes. So once you've gotten rid of the coefficients, then you ensure you have one term on either side, isn't it? Yes. So on this side of the equation you will have, you factorize log to base 3 outside, meaning here you will remain with the x. Subtraction changes to division. So it is x divided by 2x raised to power a half, isn't it? So if you do that, to be equals to what? The other side, if you factorize that, log base to 3 outside, you remain with 3 raised to power. Are we together? So you can join this. If you look at this, you now ignore the log on both sides of the equation because you made either side of the equation to be one term, isn't it? So what is this? Remember, if you have 2x raised to power half, loss of indices, meaning this half is power of everything. Are you seeing? Yes. Meaning it is 2 raised to power half, x raised to power a half. Are you seeing that? Yes. So, if you see that, you can now clearly see that here we remain with the x over 2 raised to power half times x raised to power half, isn't it? To be equals to 3 raised to power 2, to be equals to 3 raised to power 2. So the first thing you do is to get rid of this 2 raised to power half. What do? So you multiply both sides of the equation by 2 raised to power a half. Then you remain with x over x raised to power half. Same base with subtraction, with division you subtract the powers, isn't it? Yes. So here it means we have x 1 minus a half, loss of indices. Same base with the division sign you subtract the powers. Are we together? Yes. So it is x 1 minus a half, you remain with x raised to power half, isn't it? So x raised to power half is equals to 3 squared times 2 raised to power half. So for you to get x, what do? So you multiply both sides by 2. Are you seeing that? Yes. So you raise not to multiply but you raise both sides to power 2. So that 2 times a half you remain with the x, isn't it? To be equals to what? 3 raised to power 2. This power outside multiplies all the powers inside because we have multiplication sign. This dot is multiplication, remember. Are we together? Yes. Loss of indices, isn't it? Yes. So here it means 2 times 2, you get 3 raised to power 4, then times 2 times a half, you get 1, isn't it? Yes. So you remain with the times 2 raised to power 1, which is just 2, isn't it? Yes. 3 raised to power 4 is 81. 81 times 2, you get 162. So the solution of that given problem, x is 162. Meaning you just apply loss of indices where it applies, isn't it? You don't need to force yourself by finding the square root of 2 like that to get decimals for no reason. And you'll find there is a part where it will cancel out, isn't it? Yeah, you have to be very consistent with your operations.